Hey, this is the last lesson of new content for this year. So this is Unit 9B, Part 2 lesson. So here's the homework from last night. Okay, putting it all together. This is going to be a full t-test for slope. I'm going to show you the long way to get some of this, and then the shortcut way, should you choose to use the shortcut. So what are we doing? We're doing a t-test for slope. Most commonly, the null is beta is going to be 0, right, for most of these tests. There's no linear relationship. There's nothing going on here. So child development researchers explored the relationship between the crying of 38 randomly selected infants when they're 4 to 10 days old and their scores on the aptitude test later in life. Oh, that's interesting. They thought that infants who are more easily stimulated might cry more often as an infant, but also develop faster. A snap rubber band on the sole of a foot causes infants to cry. It's true. The researchers recorded the crying and measured the intensity by the number of peaks in the most active 20 seconds. Fascinating. The intensity of crying. Several years later, they recorded the aptitude score for each child. Okay, so study the graphs and the computer output for a least squares regression line analysis of data. Okay, so here's the data. Oh, interesting. So maybe crying is a good thing. I had not thought about this. Count of crying peaks. So this is the residual plot for that guy, which looks pretty scattered. That's good. And then the residual, in this case, a histogram. And there's all the output. Okay. So do these data provide convincing evidence that the alpha is 0.05 significance level of a positive linear relationship between cry count and letter aptitude score on a population of infants? Okay, so what's the first thing we want to do? So let's do the null and the alternate here. So the null is going to be beta equals 0. The alternate is that beta is greater than 0 because it says a positive linear relationship there. And then you want to find what beta is. Beta is the true population slope of the regression line when y equals aptitude, score later in life, and x equals crying for a group of infants. Let's see what they said for this first part. So there's your null and alternate, where beta is the slope of the population regression line, where y is the aptitude, x is the crying peak in the population of infants. And don't forget to mention alpha is 0.05. So they did say it. So if they didn't say it, you'd assume that anyway. Okay, plan. So what is this? This is a t-test for slope, right? That's what this is. And you check the conditions. Let's go back to the, we almost need to see the graphs. I like this one here. Okay, so let's see, does the data, so you go through the different tests here. So L stands for linear. And so for your reason for linear, you want to say the scatter plot looks linear and the residual plot looks scattered. That's perfect reasoning. I is independence. So less than 10% condition, I forgot how many folks were sampled, does it say? So there were 38 randomly selected infants. So 38, okay, so let's go back to there. So 38 is less than 10% of all infants in the population. N is normal, and look at the graph. The histogram of the residuals shows no outliers and no strong skewness. So something like that for normal. And then for E is equal standard deviation. This is the hard one to show or talk about. So as I look at the residual plot, for each x value, there's no pattern. There seems to be points above and below the line, so there's no pattern there. So that's good. And then R is random sample, a set of random sample of 38, I believe. So let's see what they said for the conditions. So linear. And the residual plot is fairly random scatter. Normal, the histogram shows no strong skewness or obvious outliers. Equal standard deviation. The residual plot shows a fairly equal amount of scatter around the horizontal line at 0 for all x values. That's true. Random sample of 38, and then finally 38 is less than 10% of all infants. Okay, so we've done all that. So now let's do the do part here. So 2 ways to do the do part here. So let's get this. So the way we taught you yesterday, I taught you the long way, and that's okay. It's good to learn the long way. In fact, I sometimes use the long way. It's not bad. Okay, so t equals the slope, which is 1.4929 minus 0 technically, because that's the null, over 0.4870, which is that standard deviation. So let's get our calculator out and type that in. So as a fraction, we're going to type in 1.4929 minus 0 over 0.487. And I get 3.07. Does anyone see the shortcut? What's the number next to that standard deviation? Right next to 0.487, it says t is, oh my goodness, it says t equals 3.07. You could just grab it from that. Okay. So now the next step would be to draw this, t curve. It's a very bad t curve, but it is what it is, 3.07. So somewhere right out there is t equals 3.07. You're shading to the right. So you would get out your calculator and do the tcdf command. So I'm just going to type tcdf. I think it's 3.07 to infinity, and then degrees of freedom, I think it was 36. Does that sound right? I think that's right. 0.002. So the p-value is 0.002. P-value equals 0.002. Now, if you see it, the shortcut, do you see the number right next to 3.07? That's 0.004. It says p above it. So that's for a two-sided test. This is a one-sided test, so you have to do the 0.004 divided by 2. So because it's a two-sided test, you take that 0.004 p-value divided by 2 to get 0.02. That's the shortcut, if you choose to use it. Okay, so they did the shortcut, actually. So the conclusion, because the p-value of 0.002 is less than the alpha level of 0.05, we have convincing evidence that there is a positive linear relationship between crying and intelligence or aptitude there, and that's what they said for that one. You can do this in your calculator. I don't recommend it. They're going to give you the output. There's no reason to type in all this data in there. It's just too much. I mean, look at all that data you'd have to type in. Oh my goodness. So we're going to just skip that part because I really want you to do it using all the outputs, which is what they give you in this chapter. So colleges and universities that are difficult to get into often considered prestigious, but are they also a good value for their students? It's actually a really good question for our students. A curious teacher visited the website niche.com for a random select of 20 traditional four-year colleges, universities, for listing all such U.S. institutions. For each school, X is the acceptance rate and Y is the median earnings of its graduates. Oh, I like this. Here are oh wow, the acceptance rates and earnings. So if it's less acceptance rate, you get higher earnings, evidently. Do these data provide convincing evidence at the 1% significance level of a negative linear relationship between the acceptance rate and the earnings? Okay, so let's just kind of go through this. So you would start by saying, let's see. So what's the null going to be for this one? So beta is 0, the slope is 0. The alternate is beta is less than 0. Define what beta is. Beta is the true slope of the population regression line when X is acceptance rate and Y is median earnings. Okay, so we've done that. This is a t-test for slope is the name of it. You're to go through the conditions. So L is linear. The scatter plot looks linear and the residual plot is scattered. Check for linear. I is independence. 20, so there'd be 20 is less than 10% of all select college universities. N stands for normal. If you look at the residual dot plot there, so the dot plot has no outliers and no major skew. Ooh, it's not great, but we'll take it. And then equal standard deviation, if you look at the residual plot for each x value, it seems somewhat scattered. There's no pattern there. So that's good, equal standard deviation. And then R is random sample. It said it was a random sample of 20 traditional four-year colleges. Let's check. Okay, so for T, for the do section, it's going to be negative 0.413 over 0.079. And I know what it's going to be because I'm looking at the shortcut and it's negative 5.242 if I type that in my calculator. I like to kind of draw this, so negative 5 is way over here. So you'd go to your calculator, you do TCDF, negative infinity, comma, negative 5.242, comma, degrees of freedom is, I think 18, because there are 20 colleges. So wow, that number is very, very small. So by the way, if you took the number there, that p-value, you'd have to divide the 0.01 divided by 2, although it's actually like less than 0.01. It was so small, they just didn't even put it there. You'd have to divide that one by 2. Anyway, it ends up being a number. Your p-value is approximately 0, which is fine to say when it's that close to 0. And so, and then you can make your conclusion. Let's see what they did. I just wanted to do some of those steps there with you. They took the shortcut 0.001 divided by 2. Because the p-value is very small, close to 0, we reject less than 0.01. We reject the null. These data provide convincing evidence of a negative linear relationship between the acceptance rate and median earnings. Okay, good. That's your lesson for today.